Hello students. Now I am now opening a new sub channel for CBSE math from standard 6. The first chapter sets some of our students cannot realize how to solve their questions from the beginning. I will tell them to start the theory of the mathematics. That is very important. So let us start from the beginning, standard 6. And I hope that you will also with me. Now start. Sets, most important chapters, class 6. In these days of conflict between ancient and modern studies, there must surely be something to be said for a study which did not begin with Pythagoras and will not end with Einstein, but is the oldest and youngest. G. H. Hardy. And let's the introduction. The concept of set serves as a fundamental part of the present day mathematics. Simple language, and I will discuss it with you, that set is a fundamental part of mathematics. Today, this concept is being used in almost every branch of mathematics. Yes, today without set, you cannot go forward with mathematics. So, sets are used to define the concept of relations and functions. The study of geometry, sequences, probability, etc., requires the knowledge of sets. Now, knowledge about the importance of sets. If you want to start a chapter, you should begin with the introduction. That is why I want to discuss with you from the beginning, and who are not able to realize truly, they must start with the beginning. The theory of sets develops by German mathematician George Cantor, 1845 to 1918. He first encountered sets while working on problems on trigonometric series. In this chapter, we discuss some basic definitions and operations involving sets. Sets and representations. In everyday life, we often speak of collections of objects of a particular kind, such as a pack of cards. You know, a pack of cards, there are many cards in the pack. A crowd of people, many people, a cricket team, wicket keeper, bowler, batsman, a group of player, etc. In mathematics, also we come across collections, for examples, of natural numbers, points, prime numbers, etc. More specially, we examine the following collections. Now start. Students, please follow minorly and don't bore with reading the theory, because if you want to strong with your mathematics, you should go through the theory of the mathematics. Now let us 1. Odd natural numbers less than 10. Look at the look at and open your book. Odd natural numbers less than 10. 1, 3, 5. Okay. 1, 3, 5, 7, 9. Odd, not even. 1, 3, 5, 7, 9. Less than 10. You know, the rivers of India. The rivers of India. There are many rivers in India. All the collection of rivers, the rivers of India. This is the set. The vowels in English alphabet, namely A, E, I, O, U. Understood? Various kinds of triangles. Yes. Various kinds of triangles. Prime factor of 210. What is 2, 3, 5, 7? This is the prime factor. Understood? Next, the solution of the equation x square minus 5x plus 6 is equal to 0. That is 2 and 3. X is equal to 2 and 3. So, we note that each of the above example as well is well defined collection of objects in mathematics. Now you can understand in these examples of the set the sense that we can indefinitely decide whether a given particular objects belongs to a given collection or not. For example, we cannot say that the river Nile does not belong to the collection of rivers of India. Nile river is not in India. That is, the collections of rivers of India, Nile does not belong. Understood? On the other hand, the river Ganga does belong to these collections. Okay. We give below a few more examples. Of sets used particularly in mathematics. The set of all natural numbers. 1, 2, 3, 4, 5, 6 and so on. The set of all integers. Yes. The set of all rational numbers. The set of real numbers, all are sets. So students, you know about the set of mathematics. The set of real numbers, the set of positive integers, the set of positive rational numbers, and the set of positive real numbers. The symbols for the special sets given above will be referred to throughout these texts. Okay? Again, the collection of 5 most renowned mathematics of the world is not well defined because the creation, the criterion for determining a mathematician as most renowned may vary from person to person. Thus, it is not a well defined collection. Again, the collection of 5 most renowned mathematicians of the world is not well defined. Okay, so we shall say that a set of well defined collection of objects. The following points may be noted. Objects, elements, and members of a set are synonymous terms. Okay. Objects, elements, and members of a set are synonymous terms. Sets are usually denoted by capital letters A, B, C, D, X, Y, Z. So, the elements of a set are represented by small letters. Sets are denominated capital letter, and the elements of the sets are as small letters A, B, C, D. Okay. If A is element of a set capital A, we say that A belongs to A. The Greek symbol epsilon is used to denote the phrase belongs to. Okay, thus A belongs to A. If B is not an element of a set A, we write that B not belongs to A. Epsilon, the symbol is epsilon, and read B does not belong to A, as I say. Thus, in the set V of vowels in the English alphabet, A belongs to V, but B not belongs to V. In the set P, the prime factors, P for prime factors of 30, 3 belongs to P, but 15 not belongs to P. There are 2 methods of representing a set, a roster or tabular form, or set builder form. Now slowly we enter in the set theory. Now students, please attention and go on study with me the theory of the mathematics. If you can grow your depth in mathematics, you should go through it. In roster form, all the elements of a set are listed. The elements are being separated by commas and are enclosed within brackets, third brackets. For example, the set of all even positive integers less than 7 is described in roster form 2, 4, 6 within third bracket. Some more examples of representing a set in roster form are given below. the set of natural numbers, the set of natural numbers which divide 42 is within roster brackets 1 2 3 4 5 1 2 3 6 7 14 21 42, the set of natural numbers which divide 42. Understand? Now, in roster form, the order in which the elements are listed is immaterial. Thus, the above set can also be represented as 1, 3, 7, 21, 2, 6, 14, 42. Now, the set of all vowels English alphabet is A, E, I, O, U. The set of odd numbers is presented by 1, 3, 5 and so on. The dots tell us the list of odd numbers continued indefinitely. Note, it may be noted that while writing the set in roster form, an element is not generally repeated. All elements are taken as distinct. For example, the set of letters forming the word school is SCHOL. So there are no repeated words, no repeated letters, no repeated digits. Understood? So, or HOLCS maybe. Here, the order of listing elements has no relevance. Number 2, in sets, in set builder form, all elements of a set possesses a single common property which is not possessed by any element outside the set. For example, in the set AEIOU, all the elements possesses a common property, namely each of them is a vowel in English alphabet and not other letter possesses this property. Denoting this set by V, we write V is equal to X is to X. X is a vowel English alphabet. It may be observed that we describe the element of the set by using a symbol X and the other symbol like letters Z, etc. So, it may be observed that we describe the element of the set of using a symbol X. Any other symbol like letters Y, Z, etc. could be used. V is equal to within bracket X. X means vowel in alphabet. X is a symbol of all English vowel alphabet. Understood? With a single letter we symbol it. So next, which is followed a colon. Any other symbol like letters Y, Z, etc. can be used, which is followed by colon. After the sign of colon, we write the characteristics property possessed by the elements of a set and then enclose the whole description within braces. The above description of the set V is read as set of all X such that X is a vowel of the English alphabet. In this description, the braces stand for the set of all. Understood? The colon stands for such that. For example, the set A is equal to within braces X is to X is a natural numbers and 3 less than x less than 10 is as read as the set of all x such that the set of all x such that x is natural number and x lies between 3 and 10. Hence, the number 4, 5, 7, 8, 9 are the elements of the set. So, we read as a the set of all x such that x is natural number. Here x is natural number. Next, if we denote the sets described in A, B, C above roster from capital A, B, C respectively, then A, B, C are also represented in set builder from as follows. A the set of all x such that x is a natural number which divides 42. Next, the set of all y such that y is a vowel in the English alphabet. The set of z, all z such that z is an odd natural number. C is equal to. Example, the solution of the equation x square plus 2 minus x in roster form. The given equation can be written as x minus 1, x plus 2 is equal to 0, where x is equal to 1 minus and minus 2. So, therefore, the solution set of given equation can be written in roster form within braces 1, comma minus 2. Understood? Example, the set of within braces x such that x is a positive integer and x square less than 40 in the roster form. And here is the example solution, the required numbers 1, 2, 3, 4, 5, 6. So, the given set in the roster form is 1, 2, 3, 4, 5, 6. Example, we write the set A is equal to 1, 4, 9, 16, 25 in the set builder form. Solution, we may write the set A as A is equal to x such that x is a square of a natural numbers. Understood? 1, 1 square, 4, 2 square, 9, 3 square, 16, 4 square, 25, 5 square. Understood? Alternatively, we can write a is equal to x such that x is equal to n square, where n belongs to capital N. Okay. For example, 4. Write the set half, 2 by 3, 3 by 4, 4 by 5, 5 by 6 and 6 by 7 in the set builder form. We see that each member in the given set has the numerator 1 less than the denominator. Okay, 1 numerator, denominator 2, numerator, denominator 2, numerator. Here we see that each member in the given has the numerator 1 less than the denominator. Denominator 2, the numerator 1. Denominator 3, numerator 1. So, and the numerator begins from 1, 1, 2, 3, 4, 5, 6. And denominator begins from 2, 2, 3, 4, 5, 6, 7. So, x, so within braces, x is such that x is S n by n plus 1, where n is a natural number, or n 1 less than equal to n less than equal to 6. Example 5. Match each of the set of the left described in the roster from which the same set of right described in the set builder form. 1. PRINCAL. Here x is such that x is a positive integer and is a divisor of 18. That is why 0 within brackets 0 b x is such that x is an integer and x square minus 9 is equal to 0. Number 3, 1, 2, 3, 4, 5, 6, 1, 2, 3, 6, 9, 18. So see, x is such that x is an integer and x plus 1 is equal to 1. And next 5, 3 minus 3. X is such that x is a letter of a word principle. Solution. Since in D there are 9 letters in the word principle and 2 letters P and I are repeated, so matches D similarly to matches C, and x plus 1 is equal to 1 implies x is equal to 0. Also 1, 2, 3, 6, 9, 18 are all divisor of 18, and so 3 matches, and finally x square minus 9 is equal to 0 implies x is equal to 3 comma minus 3, and so 4 matches P. And here is the end of the first chapter set before 1 plus 1 exercise. Now next day we will do with you and help of theory from the beginning. We will try to understand the most important chapter set. So please keep with me, and we'll meet again next day. Bye bye.